Well, good afternoon, everyone. Thanks for attending this Mars webinar on precision hand tools. Today's topic is fixed plug gauging, air gauges versus mechanical. Which is right for me? I'm George Schutz, Director of Precision Gauges, working out of Providence, Rhode Island. And if you have any questions during the presentation, use the chat feature and I will respond to your question after the webinar by email. So today we're going to learn about precision bore gauge systems from ARM. We're going to see why we're going to use a fixed plug as a comparison to other types of plug measuring systems. What are dimension plugs and how do they work? What are air plugs and how do they work? And then we're going to go in and decide which might be the best for our application. But the first thing I want to talk about is the subtle differences between measurement and gauging. These terms are often used interchangeably, but there really is a difference, and it can be a significant difference. So I think measurement is the process of determining a dimension of a part by comparison to a standard, while gauging is a process of determining whether the dimension is smaller or larger than the standard. They sound kind of similar, but let's dive into this and see what the difference really is. So measuring instruments use an internal scale, and the measurement of the part is compared to that internal scale. So all measuring instruments have the standard built into them. They tend to be relatively slow and require more skill for accurate measurements. They're very versatile and can measure a wide range of dimensions, but because of operator influence and the way the gauges are designed, they generally have a greater measurement uncertainty. So these are examples of basic measuring instruments. They all have the scale built into them. So you're familiar with micrometers and calipers, even the scales themselves, which have the lines etched into them. That is basically the reference standard that we're comparing the part to. But you can have bench-mounted measuring instruments, such as height gauges, laboratory universal length machines, or even shop floor length machines. But you can see that, they have lots of versatility. They can measure lots of different things. And because of that, they tend to be a little bit slower for the operator to use. But under the right environment, especially with universal length machines, you can get some very good results. So digital calipers are an example of a measuring instrument. MAR makes a whole family of these, whether wireless or specialty calipers, depth gauges, and so forth. These are measuring instruments, as are micrometers, with their capability of different sizes, different ranges, different features, and so forth. So there's a whole family of different digital micrometers. Now, gauging instruments are a little different, like I said. They determine whether the dimension of the part is smaller or larger than a predetermined standard. So gauging instruments have external standards. They tend to be faster and more accurate than measuring hand tools. Because of their design, they're generally more dedicated to the task, and gauging instruments can be defined into different levels of performance. The first level of performance for a gauging is a adjustable variable gauges. They indicate how much the part deviates from the standard was set to. They can be adjusted to measure a specific size, but they have a limited measuring range with a lot of adjustable range. They provide the actual deviation, so you can get a data out from that indicator if you like. With these types of gauges, the operator has to sweep the part to capture, in the case of a bore gauge, the minimum size or the reversal point to get that diameter. So therefore, the gauges take some operator skill, but a skilled operator can be very fast, use the gauge with lots of ease, and get some very good results. All these gauges, like I said, with any of the gauging products, have an external standard, typically the nominal master, and these can have a fairly large investment, but they can last for decades when well maintained. And by exploring the part, you can learn about the form, use that information for process trends, and maybe diagnose manufacturing issues. So these are some of the adjustable variable gauges that are offered by MAR. Our adjustable bore gauges and our ID/OD portable gauging systems. Now you can take an adjustable variable gauge and add a reference to it, and that really increases the capabilities or performance of the system. So variable gauges with a reference, again, indicate how much the part deviates from the standard the gauge would set to. They can be adjusted to measure a specific size. They incorporate a reference stop, which really helps position or lock the part into a repeatable place for measurement. So that really reduces the operator influence, and you always can get the part back to the same location. So these require very little operator skill. They can be extremely fast and easy to use. Again, these variable gauges have limited measuring range, but a lot of adjustable range. And again, because they're variable gauges, they provide actual deviations. One master is required for setting. Again, it's a big investment, but these gauges, again, last for decades if well maintained. And of course, you can explore the part for form, process trends, and diagnose manufacturing issues. So these are some of the adjustable variable gauges with reference that MAR provides. Snap gauges for portable measurement. You can bench mount them. Plus, we make some ID/OD gauge in 2 or 3 point contact systems to measure IDs and ODs. Plus, if you have a stand and you put a backstop on it, that also increases the capabilities and repeatabilities of that gauging system. And then there's fixed variable gauges. These are variable gauges made to a specific size. They tend to be the most accurate. They again provide actual deviation, so now you can collect that variable data. These have the least operator influence. The operator simply puts the plug gauge, for example, into the bore. There's no rocking, there's no centering. The gauge finds its own center. So it's the fastest to use with the highest performance. Of course, these gauges measure only one size, so they're dedicated to that function, but you can really learn more about form, process trends, and information to improve that process, because you can get some very good results with very high resolutions. For measuring a single bore, this is the largest investment, but again, these can last for a very long time and in fact last millions of parts when used properly. Again, one master is required, a setting master for the nominal size. So MAR offers a number of fixed variable gauges. These are plug gauges, our Dimension plug line, our 844D ID plugs, and air gauging. All these plugs are made specifically to measure a certain size and tolerance. I like this little chart here that kind of rates the performance of the different types of gauges. We talked about measuring instruments, adjustable variable gauges with a reference, and a fixed variable gauges. And you can see hand tools have the greatest versatility, but they lack speed of measurement. They lack the ability to make good measurements because of the operator skill that's involved. They're a little bit harder to use, and they don't give you as good a performance as the fixed variable gauges. This is the top of the line. This will give you the best measurement, the fastest possible and easiest way of doing it. So once you start talking about fixed plug gauging, you have to realize there's some qualifications for that. You have to have a pretty good tolerance condition. Tight tolerances are meant for fixed plug gauging. You want to know when that part is good or bad, and you want to know that variation so you can do something with that information. Usually these types of gauges are used when there's a high volume of parts because it allows the operator to measure that part as fast as possible with as little influence as possible. But sometimes, fixed plug gauges are used in applications where the volume might be low, but there might be no other way to get the performance that's required. And sometimes these plug gauges can be used in to help find geometric conditions, and we'll talk about some of those because there might be no other way of doing that type of measurement out at the point of manufacture. So we said that we supplied two types of fixed plug gauging, our mechanical plugs and air gauging. And if you compare them, there's different qualifications for each one of them. And now let's take a look at the differences and the different applications for a mechanical fixed plug gauge or an air fixed plug gauge. So with mechanical plug gauges, we say that we want a tight tolerance. So, tight tolerances are, plus or minus 10,000ths of an inch or so. High volume of parts, little operator skill, all the features of a fixed plug gauge. These can get some pretty good accuracies, 10 microinches. We're going to know the variation. Because there's mechanical transfers in the way these gauges work, they have to be used in a fairly clean environment. Most of these plugs have a flow-through type of operation, so you can clean them out. But the mechanics and dirt just don't mix sometimes, and we have to make a consideration for that. They can be used in a shop environment. They're very low cost to operate. The nice thing about mechanical fixed plug gauging is that they're very portable. There's no air supply or cables or anything like that to get a good measurement. So a person can carry this around, put it into the machine tool, make the measurement, and they use this truly at the point of manufacture. You can get some limited versatility for geometric measurement. By that I mean you can explore the part for a ovality condition or potentially a straight or straightness taper type of condition. So you can get some information about the form of the part. And overall, these cost probably a little bit less than air gauging. So like I said, we make our Dimentron plug lines here in Providence. They're very, very rugged. They have a standardized zero reference, which means that you can take any plug, exchange it with the handle or the display. The zero is set to within a certain tolerance. They're fully interchangeable, and you have to make any adjustments when interchanging plugs. These types of plugs are repairable, and there's lots of opportunities for making specials of these Dimentron plugs. We also offer our 844D plug system. This is a plug made in Germany. It can be repaired. There are options for doing a zero reference. They are very rugged. There are some specials, and these offer some different types of application support. So both lines are fixed plug gauging, and there are just some slight differences between them, which can be considered when trying to measure a precision bore. they have very similar measuring and specifications, size ranges, etc. So when you're considering a fixed plug gauge, a mechanical one, you should know how they work, what the sizes are offered, the actual measuring range of the specific plugs, how to match the part tolerance to the plug range, what are the standard configurations, the different displays that can work with them, and any other tools, that information that might help you select the right plug. Well, MAR has a very good technical support team in Providence. So if you have applications for mechanical fixed plug gauges, you can contact us with the diameter, the tolerances, the application needs, and we can make the best recommendation for that application. Is selecting that fixed plug mechanical gauge black magic? Well, not really. Applying a Dimetron or the 844 is no different than selecting an adjustable bore gauge, an air gauge, or a snap gauge. You have to know what the size is, what the tolerance is, and where that measurement is. But because it's made to a specific size and application, you make a mistake in specifying it, it's going to make a plug to the wrong size and you might not be able to use it. So it's very critical to ensure that the size and tolerances are specified correctly for a fixed mechanical plug gauge. So what makes up that plug gauge? Well, basically you have a hardened steel cylinder, and we have different coatings that can be applied to that for longer wear. It's a 2-point mechanical transfer mechanism that's built inside that plug. Then you have an adapter, which is the connection between the plug and the readout system. And then you need some type of display that relates the transfer motion to a diameter. So that can be a dial indicator, a digital indicator, a bench amplifier like our C1200, for example. And then you need a setting master. So those 5 points or 4 points make up a complete measuring system. So basically what's inside a mechanical plug is a number of contact points, 2 contact points on either a spring or a flexure that, when compressed by the bore diameter, pushes the V-rod back out of the plug, and then we have a display unit measuring that variation. So you can see as I go back and forth here, the V-rod is pushed back and the measuring instrument records and looks at that value. So it's a very simple concept, but it provides a 1-to-1 ratio of the V-rod to the movement. So there's no compensation needed for display using the plug gauge systems. And because it's a 2-point measuring system, kind of a differential measuring system, the body or the plug can be, with it, even with its small clearance, you can move it slightly. You will not get any variation in the diameter, because as one contact moves in, the other one moves out, and you still get the true diameter of the part, whether you're measuring that part axially or radially. So you have a continuous online indication of the part diameter. And because of that, you can now take that plug gauge and put it into the bore, measure the diameter, but now you can rotate it or move it up and down axially in the bore to explore the bore for barrel shapes, taper, or hourglass shapes of the bore. We also make a blind hole plugs or through hole plugs, so that depending on the bore application, we can get as close to the bottom of the bore as we can. So blind hole plugs have a dimension of 157 thousandths of an inch to the bottom of the plug, We can make plugs that are closer down to 80 thousandths. And we also have a super blinds family that can get down to 31 thousandths to the bottom of the blind hole. And plug starts at 120 thousandths, and we can make plugs up to 9 inches. And even special larger sizes are available. So we can cover a full range of different tight tolerance bore characteristics with mechanical plug gauging. So the features of our plugs are that they're engineered for a high production use. They have a hardened body. They can be flash chromed or coated with a diamond-like coating. We use carbide contact points, but we do offer options for steel or sapphire when the material of the bore requires those types of contacts. You get very good repeatability and excellent GR&R capabilities. Calibration accuracy is better than 2% of the full range. I talked about flow-through cleaning so that dirt will not stay in there if the plugs are cleaned on a regular basis. And they are self-centering differential measurement the way they work so that they can give you a true diameter regardless of the orientation in the part. So that's kind of the overview of mechanical plug gauges. Let's take a look at air gauging applications for bores. Air plugs can measure a tighter tolerance, tolerances that are plus or minus 3 thousandths or smaller. Again, because they're a fixed plug system, they're good for a high volume parts, offer the operator a very easy to use system. Now you can get accuracies of 5 microinches or better for, especially for repeatability, because these are used over such a small range, and you can get very high resolution applications. Again, we're going to know the part variation. The nice thing about air gauging is because air is flowing out of the system, it tends to clear away any water-based contamination in the bore. So these are really great items to use at the point of manufacture in those harsh environments. They tend to be a little bit higher cost to operate, but they can give you a much higher performance measurement. Because air plugs have a hose to them, there are, that kind of restricts portability a little bit, but the air hoses are very flexible and can go up to 10 feet with no problems and still use that air plug in the machine at the point of manufacture. And the nice thing about air plugs, as we'll see in a minute, is that they have more versatility for geometry measurements. So why use air gauging? Again, it's a fast, self-aligning measuring system, very high resolution, very easy to use. It's non-contact. It doesn't have contact points like a mechanical plug gauge. Of course, because it still has a body that touches the bore, the plug is contacting the bore itself, but the measuring part is non-contact because it's using air back pressure to make its measurement. And it's kind of a self-cleaning type of plug where the air clears away any water-based surface contamination. So again, we use these in a tight tolerance condition. We want to know the variation. We want to make the measurements quickly, especially for high volume applications with minimum operator influence. Again, because they offer such a high degree of performance, you might have a very large diameter in a low volume part, and there might not be any other way of making that measurement on the shop floor than air gauging. So air gauging, despite its cost, might be the best way for some low volume applications. And air gauging gives us more capabilities of looking at the part for taper, straightness, center distance, etc. And it's great, like I said, for the environment when it's at the machine and it might be a little bit dirty. So is air gauging difficult to apply? Well, not really. It's the same as the mechanical plug gauges. It's the same type of questions you have to ask about any application. You have to know the part size, the tolerance, where the measurement is to be made. And what's important with air gauging is we should know what the surface finish is. And since the air gauging is custom made, just like the mechanical plug, any mistake in specifying the tooling could result in an unusable measuring system. Same questions to ask for any dimensional gauge application. Now, how does air gauge work? Well, it works on the idea of back pressure. So, just like you might hold a garden hose against the wall and you close the distance and the water is going to spray off until it's finally shut off. Well, something's happening to that water pressure that's in the hose. It increases as the distance decreases. So water and air act very similar, and you can do the same thing with an air gauging system. If you plot out airflow or the pressure in the hose, you get two opposite pressure or distance curves or a flow distance curve. So you can see on the pressure side here, as the distance between the jet or the nozzle decreases, the pressure increases. And as the spacing increases, the pressure decreases. So if you can control the pressure, the jetting, whole dimensions, you can create a very straight linear part of this curve. And that's what we use to determine diameter by air pressure. And this is the basis for all our air gauge systems. When we can control the air pressure, the manufacturer and position of the air jet, the manufacturer of the air plug, and calibrate and zero location of pneumatic zero, we can get very repeatable and accurate results. And these results can be used as the means for displaying a dimensional measurement. And this is the basis for all of our air gauge systems. They're all made to a common standard, interchangeable, just like our mechanical plugs. So the air plug is nothing more than a hardened steel cylinder with passages for opposed jets. So these are examples of two jet air plug systems. The air passes through the probe and comes out of the jets. The proximity of the part throttles the airflow, resulting in the pressure changes back towards the instrument. And the air gauge instrument measures that back pressure and displays the part size. Again, if we can control all the characteristics of the plug, we can provide a very accurate measuring system. And it really all comes down to the air jet itself. The pressure distance curve is dependent on the jet which the air flows through. And the air tool basically is a steel cylinder that holds those air jets. Again, as the air jet is restricted, we are measuring what is happening to the air in the system. Now you can see that the jets in this air plug on the right here are very small, and that's a very important feature. I think it's probably the greatest feature about air plugs is that the jets themselves, which are really sensors, can be positioned very close together. And I don't think that there's not too many other sensors that can do the same thing at the cost of an air plug. No, so typically you can put jetting as close as 100 thousandths of an inch, but sometimes even closer. So now this provides the capability of doing multiple dimensions or geometric checks in a single tool. So here's a couple examples of multi-circuit air plugs doing multiple diameters at different levels. And you try and consider doing this either with, I don't know, mechanical transfers or probes or something like that. It'd be nearly impossible to do something like this, again, out on the shop floor and get good results. So with an air gauge system, you have kind of the same types of components. You have the air tool, a handle, and a hose. You have a readout, and you have a master. So with these three parts, you can create an air gauge system that's fast, easy to use, highly accurate. You get some good resolution, it's non-contact, and it's great for in the shop environment. And again, air plugs are very similar to mechanical bore gauges. They allow us to explore the part for size, ovality, barrel, taper, and hourglass. But because of their higher resolution, we can measure tighter diameters and control those form errors even better. Now we talked about knowing surface finish as part of the part size and tolerances. Well, surface finish is important with air gauging because, as you can imagine, and we saw that the jets have a certain diameter. And in order to throttle that jet, you have to close off the surface. If that surface is rough, it might have some peaks and valleys to it. And air has to fill those valleys to create the back pressure. So what's kind of happening there is that the zero for that point of the back pressure might be below the peaks of the surface. Now you think of a mechanical plug gauge, for example. A mechanical plug gauge is going to ride along the peaks or the high points of that surface. So if you have a mechanical plug gauge riding on the peaks and an air gauge that has a very rough surface reading something below those peaks, you could get a discrepancy between those two types of measuring solutions. So it's very important, if you have a very tight tolerance, to know and understand the surface finish of the part. You know, for most general applications, surface finish should be, say, something in the area of 40 RA or less in inches, and that will tend to give us anything better than that will tend to give us the best results. Now you can get different types of air plugs. You know, we talked same concept here about through bore air plugs, blind and super blind. We can make longer air plugs that could be relieved or non-relieved. We can put stop collars on air plugs. And then you can talk about the number of jets that are built into the plug. The most common use is to have a 2-jet system, and this is typical for measuring IDs and ODs. A 3-jet plug will help identify odd number of lobes for form error. We'll take a look at that in a minute. We can also make jets with 4 or 6 jets that can give us average diameter or the average of a 2 and 3 lobe condition. So there's lots of capabilities and possibilities for air plugs. And this is great for measuring parts where the form error is known. Now, depending on how parts are manufactured sometimes, they can have a even number of lobes or an odd number of lobes generated in them because the way the part might be held or fixtured. A 2-point measuring system is great for measuring the bores that have an even number of lobes, like the diameters shown on the left here. So as we take that 2-point contact system and rotate that in the bore, we're going to see the large and small diameter. If you took that same type of plug and put it in the bore on the right, you would see one constant diameter. So a 2-point measuring system is not the right way to make a measurement on a bore that has an odd number of lobes like this one has with its 3-lobe condition. So knowing that, if you did a form measurement and you know your parts have this type of condition, we can provide a 3-jet air plug specifically designed to measure the diameter of these types of parts. And this really ensures better fit or better match of IDs and ODs when doing an assembly of a number of parts. So air gauging offers a lot more flexibility. And because of the small jets, we can put the jets closer together to do multiple dimensions in a single plug of the same or different diameters. We can also make plugs that have floating heads, making multiple diameters where the concentricities of the part may not be that ideal for a standard fixed body air plug. So we have thousands of different air gauge applications, multiple diameters, multiple sizes, multiple jets, and tapers are another great application for air gauging, whether it be a machine tool taper or a orthopedic taper, where we can measure 2 diameters at a known distance and we can provide taper angle. So some of these medical tapers are very small, and again, because the jets can get so close in such a small diameter, there's no other way to measure these parts and get such good, fast results. So again, with the jets, we can do point of manufacturer geometry type checks out on the shop floor. If the blueprints are called for a roundness or straightness or parallelism, you might be able to do these types of measurements with air gauging at the point of manufacture. Just like mechanical plug gauges, there's different types of readouts available. Our microdimensionaire is similar to a digital indicator. We have analog and column gauges, even PCs and bench amplifiers, all made to provide the right display options with the right resolution for the application. So why MAR for your air gauging needs? Well, again, we have thousands of tool designs over the years. We have the application people and know-how to help provide the right tool for your application. We build the accuracy into our plugs because we set everything to a known internal standard, so everything is interchangeable and is calibrated, ready to go to make your measurements. And of course, we know accuracy since we not only make the gauging, we make the masters, and we can certify and measure all the tooling and masters. So which one is the right method for you? Is it a mechanical plug gauge or an air plug gauge? Well, again, you have to ask the questions. What's the tolerance? What's the application? Where is it being used? What's the environment like? All these questions help select the right tool that makes the most sense for your application. So which one do we use? Again, look at the accuracy, look at the cost, time and throughput, ease of use, cost of maintenance, part cleanliness, mobility, workpiece form and finish. These are questions and factors in selecting the right tool for the application. And you might also consider, if you want to do some data collection, know whether parts are good or bad. Do you have to do a TIR or a dynamic measuring condition? How comfortable is it for the operator to use? And what's the visibility of the operator? Does he have to reach into the machine, try and look at the gauge, or use a remote display to see that result? Do we need to do signal sharing between different diameters to calculate a taper, for example? Or do we want to bring the part to the gauge or the gauge to the part? All factors for selecting the right fixed plug gauging solution. So we've talked about a lot today. There's no true fixed answer or logic to selecting the right one, but there are lots of questions to ask. And I think if you come to MAR, we can help you answer those questions. So we've discussed the difference between measuring and gauging, the different levels of gauges and their performance. We looked about a little bit about fixed plug gauging and its performance advantages, talked about how a mechanical plug gauge works, its features, the same for air plug gauging and its features, and the factors for choosing and the questions that are needed to be asked to provide the best one for your application. And again, why MAR? Well, MAR has a broad product range for industrial metrology. We have the application competence to support you. We have a great wireless hand tool portfolio to help you reach your Industry 4.0 data collection needs. We offer promotions with the best prices that give you the highest value for your gauging requirements. And after this webinar is over, we're going to email you a link to the recording of this webinar. You'll have the ability to read up about the mechanical and air plug gauging. And of course, you can contact anytime for your application needs. So again, thank you for your attention. Thank you for being part of this webinar. If you have any questions and you sent them in, I will respond to you, and you'll soon get a recording of this webinar for future use. So thanks again, and have a great day.